Hello. In this activity, we're going to show how the ionic bonds form in ionic compounds. So let's do the first example. We need to make a compound between sodium and chlorine. Sodium a metal, chlorine a nonmetal. So it just says we need to draw the neutral atom electron dot structure before electrons are transferred and show where the electrons are going to be going. So we look on the periodic table for sodium, and we see it right here. And it has an electron configuration of 2, 8, 1, and 1 is the valence electrons. So for sodium and chlorine, we're going to drag 1 dot over by the sodium symbol. And then for chlorine, which is on the opposite side of the periodic table, we can see it is number 17, and it has 2, 8, 7. And so that means we have 7 valence electrons around it. Now, when these form ions, they are going to achieve the noble gas configuration, the closest noble gas configuration. For chlorine, that would be argon. It has 2, 8, 8. That means it needs to gain one more, chlorine needs to gain one more electron to get that configuration. For sodium, sodium is 2, 8, 1. It loses an electron to get the same configuration as neon, which is 2-8. So that means that we can say electron from the sodium transfers over to the empty spot in the chlorine. That's where it's going to go. Okay, so now we're going to draw the ion electron dot structures. This is after the electron has been transferred. So we're going to put a bracket. Sodium has lost the electron. So it's simply like this. We're going to use control period. That's going to make us have a superscript. We're going to make it plus. We're going to do control period again, and that will bring us back to normal. I'm going to leave a space because I know I'm going to have some electrons here for the chlorine. Control period, negative, because it's gained an electron. Now let's start dragging the electrons around the chlorine. And it's going to have a full 8 around the chlorine now, since it has gained that electron. And both of these are very stable, and the two ions will now attract to one another. There's our dot structure for the compound between sodium and chlorine. We call it sodium chloride. And our compound formula will just be NaCl. All right, let's look at a second example. Now we're going to do it between calcium and chlorine. So we'll write calcium and chlorine. And let's look at the periodic table. We know chlorine already has 7 valence electrons around it. And our calcium, let's look over there. Here it is. Calcium has 2 valence electrons around it. So let's put our 7. 1, 2, 3, 4, 5, 6, 7. And calcium has 2. All right, now let's put an arrow. All right, well, where's the second electron going to go? We can only use calcium and chloride in this compound. So that means we must have a second chlorine, because chlorine is where we would be receiving an electron. So we're going to make a space. It is a pain here. I didn't do that before, but and now we can make the dot structures of the ions. And since we know exactly how many of each we need, I can do that right away. So I'm going to do a chlorine ion. I know because it gained an electron, it's going to have a negative charge. calcium, it lost 2 electrons. So I know it's going to have a 2 plus charge. And then we're going to have another chlorine. If you need to change the font to fit the ions in, then that's a good idea to do that. Let's put more dots around here. These are all stable now with an octet. Now in this compound, for the compound formula, we have 1 calcium ion, so we're going to write it like this. And we have 2 chloride ions. The positive always goes first, the negative goes second. Now we're going to do control comma 2, subscript 2. And that's because we have 2 chloride ions in this compound. And that's how you do this activity. Good luck. Remember, all compounds have to be neutral. That's it.